Hey John, what are you
I
thinking
really
about?
want to bake a cake, but I have no idea how to do it.
Why not just ask ChatGPT?
ChatGPT? You mean that AI thing? How can it teach me to bake a cake?
Watch this. This is how you get a response from ChatGPT.
Whoa! That's amazing. But, how did it know?
Good question. Let me break it down step by step. Let me explain the question answering system first to make you understand how Chat works. A question answering QA system in natural language processing NLP is a type of artificial intelligence AI that automatically answers questions posed in natural language. These systems are designed to understand the question, process it, and provide an appropriate answer from a given set of data, such as documents, databases, or knowledge graphs. Types of question answering systems. QA systems can be categorized mainly into the following types. 1.1. Extractive QA. Definition. In extractive QA, the system looks for the answer directly in the text, extracting the most relevant portion, a sentence or passage, that directly answers the question. The answer is usually a snippet of text from the source. Example, question. What is the capital of France? Source text. Paris is the capital of France. Answer, Paris. Approach. The system uses algorithms to search the text, identify potential answers, and rank the answers based on relevance. 1.2. Abstractive QA. Definition. Abstractive QA generates answers in its own words, rather than directly extracting text from the source. The system may paraphrase or summarize information. Example. Question. What is the capital of France? Source text. Paris, which is situated on the Seine River, is the capital and largest city of France. Answer. Paris is the capital of France. Approach. The system uses advanced techniques such as language models, transformers, like GPT or BERT, or sequence-to-sequence models to generate coherent, concise answers. Sophisticated techniques to retrieve relevant information from these extensive sources. Example, a general-purpose QA system like Google Search. 1.3. Closed-domain QA. Definition. The system is designed to answer questions in a specific domain, such as medicine, law, or science. It has access to specialized knowledge and focuses only on that particular field. Example, a QA system that answers questions about medical symptoms using a medical database. 1.4. Open Domain QA. Definition. The system can answer questions from any domain, making it more versatile but also more challenging to implement. It relies on large-scale corpora, such as Wikipedia, and employs input processing. The first step is understanding the structure of the question. Tokenization. The question is split into individual tokens or words. How to bake a cake. How to bake a cake? Question mark. Part of speech, POS, tagging. The system analyzes the grammatical role of each word. How, WH adverb, to, infinitive marker, bake, verb, a, article, cake, noun. Named entity recognition, NR in this case, there are no specific named entities, like people, places, etc., to extract. However, cake is recognized as a type of food. The system now understands that the question is asking for a method or set of instructions to bake a cake. Information retrieval and information retrieval. The system then searches for relevant documents or knowledge that can answer the question that in this case, it may query a knowledge base or search through a corpus of recipes, such as a cooking website or a cookbook. Example of a relevant document it may retrieve. To bake a basic cake, you need flour, sugar, eggs, butter, baking powder, and milk. Preheat the oven to 350 degree F. Mix the dry ingredients, add the wet ingredients, pour into a greased pan, and bake for 30 minutes. Answer extraction. The system will extract key instructions and ingredients from the retrieved text. In extractive QA, it selects the portion of text that directly answers the question from the document above. The QA system extracts the steps and ingredients needed to bake a cake. You need flour, sugar, eggs, butter, baking powder, and milk. Preheat the oven to 350 degrees Fahrenheit. Mix the dry ingredients, add the wet ingredients, pour into a greased pan, and bake for 30 minutes. If the system is more sophisticated and is generative, it can provide a more coherent and synthesized answer that might sound like this. To bake a cake, gather ingredients such as flour, sugar, eggs, butter, baking powder, and milk. Preheat your oven to 350 degrees Fahrenheit. Mix your dry ingredients and wet ingredients separately, combine them. Pour the batter into a greased pan and bake for about 30 minutes. Answer generation. In some cases, AI does not simply copy and paste an answer, it recreates it in a way that is more natural and easier to understand. This is called abstractive QA. How does it work? Instead of extracting exact text, the AI understands the meaning and then rephrases the answer. Example: baking a cake. Imagine a system retrieves multiple recipes from different sources. 1. Mix sugar, eggs, and butter. Then fold in flour and milk. Bake for 30 minutes. 2. Preheat oven to 350 degrees Fahrenheit. Combine dry and wet ingredients. Pour into a pan. Bake. 3. To make a cake, blend all ingredients, preheat oven, and bake for 25-35 minutes. Instead of showing all three responses, the AI summarizes them into one answer. Output generation. Finally, the system outputs the answer in a natural, readable format. Depending on the sophistication of the QA system, it could output extractive answer. You need flour, sugar, eggs, butter, baking powder, and milk. Preheat the oven to 350 degrees Fahrenheit. Mix the dry ingredients, add the wet ingredients, pour into a greased pan, and bake for 30 minutes. Abstractive answer. To bake a basic cake, mix flour, sugar, butter, eggs, and baking powder with milk. Preheat the oven to 350 degrees Fahrenheit, pour the batter into a greased pan, and bake for around 30 minutes. The answer is provided clearly, so the user can follow the instructions to bake the cake. Let's take a look at the diagrammatic representation of all the steps we just discussed.
Wow, this makes the picture so clear.
Well, nothing comes without challenges, so let's just quickly take a look at them. Here we face 4 main challenges. 1. Ambiguity. 2. Knowledge representation. 3. Handling complex questions. 4. Large-scale retrieval. And in no time the cake is ready. See, told ya it was easy.
Now I understand.